I have written some more problems on set, but it seems to be very complex to came in the examination, because if it is written that the only the word problems will came. So I am just explaining the word problems, but initially I think that these problems are also important, because in previous year question I have seen this type of problem, but I think this will not came because professor had written that it will not came. So I'm not explaining in this part, but for same exams, yes, I will make another part of these problems, and this part will be done. If you need that, tell me, I will make it. But here comes the elephant in the room, that is the word problem in uh, set theory. So I will show you the most easiest and the convenient process to do that without Venn diagram, without any process, without any formula. I hope it is a one shot. I will try to make it, but if the storage doesn't support, I can do anything. I will make it into the parts, but I don't want to make it in parts because it's a fairly simple topic, so it will take some very little amount of time. So let's see. So first thing, you have to understand some topics. So what is Venn diagram? Venn diagram is pictorial representation of sets. Okay, that says that is you need to know. Then here is a box is drawn. So generally, box signifies in sets. Box signifies in discrete maths also. In any maths, if there is sets, the box, the rectangular box signifies the universe. What is universe? Let's suppose universe means there is every number, every element, every set is universe. Okay, the biggest set you can imagine, like 1 to infinity. Okay, so that is universe. Universe means it has everything. You can imagine everything that is present in universe. So we imagine all the sets in the universe. You don't have to understand the mathematical significance of universe, because there is no mathematical significance of universe. It's just a concept and pictorial representation. So don't fuck your mind in that. Just see the what I can say, the rest of the part. So there's like two circles. So what the circle do? So if we draw a box that signifies universal set, if we draw a circle in it and name it that it is set A. So in Venn diagram, circle represent sets, that it is set A, that is set B. So how we represent that it is set A? So we can show another set, that is set B, that is set B. So here we write set A and set B. So we have seen that what is like union, what is intersection, what is difference, and what is, I have not completed the like complement part, because maybe it is not important, but I will teach you, because we never know how the question will came. So let's see. So what means A and B? So let's suppose, let's take an example, that is in A there is like 1 and 2, and in B there is like 2 and 3. Okay, so what is A union B? That is 1, 2 and 3. There is all element in A and B. So let's suppose in A, that is set A, that is set A, and that is set B. Okay, we are supposing something. So in A there is like 1 and 2, and in B there is like 2 and 3. So how we will represent the union of it, that all elements of A and B. So that's why we covered it with the like straight lines. Okay, so you can make with some pen, because it's fun to do it, so you are doing it. So yes, that's it. We are selecting all the elements with this. Okay, so it is done because I have seen you in the example, so it is done. You got it right. So let's see how we will represent the intersection. So what is common in A and B? A and B, what is common? For common part, like for common part we will use intersection. So that is 2. 2 is in A and B, so A intersection B, that is 2. So yup. So that is like set A, that is set B, and there is like 1, 2 and 3. So what is common in A and B? That is 2. Okay, so and for intersection we only mark the part that is common in between them. So what is common in between them? That is 2. That's why if the sets are like this, so we generally mark the common part. Okay, because that's the significance, that's the mathematical significance of intersection. If you don't understand the Venn diagram, don't worry about it. I am just showing you because the question will or may come like this. Okay, we will just have to tackle the what I can say word problems. So as we know, it is A minus A intersection B, because from A, if we minus, that is normal minus, that is not set difference. So if we minus what is common in A and B, that is the difference. Like A equals to 1 comma 2 and B equals to 1 comma 3. So what is common in A and B? If we want to get A minus B, that should be the common part is 1, so we have to discard 1. That is the common part. How we can write the common part mathematically? That is A intersection B. So what is common in there? 1. So the answer is 2. So how we can write it like in Venn diagram format? Let's suppose it is A and that is B and we are writing like this. That is, we generally write like this. It is set A and set B. Something may be common, something may be not, but we write like this. That is set A, that is set B, there can be another set. We will say it on the problems too. So here it is. And remember, we are only marking the section that is set A. We are not marking the section that is common in A and B. We are not marking the section that is in B. We are just marking the section that is only present in B, not in here. You got me? You got it. If you don't, just tell me. Okay, what is A complement? We are marking the section, the whole universal section, the whole universal set except A. Okay. Okay. So there is like so let's suppose universal set is A, B and C, and A is like 1 comma 2. So what is A complement? That is everything. Oh, sorry. Here is I am writing. That is universal set is 1 to 3, and for A set this is like 1 and 2. So what is A complement? That is everything that is not present in B but present in universal set. That is called A complement. That is 3. Like universal set, that is like 1, 2, 3, 4. A is like 1, 2. So A complement should be 3 comma 4. You got me? Okay. So you have understood that part. Let's understand what is principle of inclusion and exclusion. Okay, so it's just a boring theory. Why I'm telling you this shit? Because you may need it. You don't need the formula. I will show you how you can memorize the formula. It's like big formula, but it can come in through the short question part. So yep, it's not short question, short question. So yep. So what is this NA? So what is NA? If I am writing A is 1, 2, what is NA is how many element that is present in A, that is 2. You got me? So what is A comma, I mean A1 union A2? That is how many elements are present in A1 and A2. Not like mathematically we write A1 or A2. So yep. So the formula is number of element that is present in A. It will be given in the question. Don't worry about it. We are not solving the word problem. It's just the prerequisite of it. Just the prerequisite. If you don't understand it, don't worry. The word problems are really easy. But this will can come in the short question. That's why I am telling this. So then there is like number of element in A2. Then we minus the A1 and A2. So let's understand why this formula came. But let's first face this. Just don't see this formula. That's fucking awkward. I mean, that's fucking tough. So first we are adding all the elements that is given in there. So A1, A2, A3. Number of elements are always there. Then we are pairing two elements. A2, A1, A2, A2, A3 and A3, A1. So let's see. Minusing that part, minusing that part, minusing that part. Got it? Then we are adding the number of element that is present in all there. That is A1, A2, A3. You just have to remember this formula in the word problem. I am trying to make you see the derivation, the Venn diagram derivation of it. You don't need the derivation in the examination, but it will make you easy to memorize the formula. So let's see what's happening, how this shitty formula came into this picture. So there's like universal set, and this is like A1 and this is like A2. So the formula is number of element that is present in A1 union A2. Okay, how it is mathematically signified you will see, don't worry about it. So let's first solve it. So first we have to see what is A union A2. So that is all elements that is present in A1 and A2. So we are marking it. Okay, so we have to say how many elements are there and there. Okay, just that. So we can say number of element that is present in A1, okay, plus number of element that is present in A2. Then let's suppose in here that is number of element present in 1 and 2, and here it is 1 and 3. You will understand it better with the formula. So what is A1 union A2? That will be 1 comma 2 comma 3. So how many elements present in this? That will be 3 because there is 3 elements. You got it? But if we write this only, how many elements present in A1? That is 2. How many elements present in A2? That is 2. So there is 4 elements. So how this is possible? This cannot be possible. What is the problem with it? The problem is, let's suppose there is like 2 in here, the element 2 in here, 3 in here, and in this middle part that is common in A2 and A3 we write that is common in between them. So what is common in between them? That is 1. So we have to exclude 1 because 1 is repeating here, 1 is repeating here. That's why element it seemed to be extra. Like there is 4 elements, seems to be there is like 4 elements, but there is only 3 elements. So what we have to exclude? The common part. So how we write the common part? That is number of element that is present in A1 intersection A2, and it's done. You got it. I hope you got it. If you don't, it's normal, it's okay. So let me take 3 example. So a1, like 1 2, I mean a2 is like, so you got the two formula, right? So let me memorize you like this formula also, that is a union a2 union a3. For rarest of the rare case, this formula will came, and if it came, just use this formula. I will show you where you have to use this formula. First you have to add 3 elements given a3. It's done. After that you have to exclude the 2 pair. Okay, you have to exclude the 2 pairs. So a1 intersection a2, a2 intersection a3, and minus n1 intersection a3. You got it? Then you have to add just for 3 elements, you have to just do it. Okay, I'm not deep diving into the derivation because it will be boring for you. Just memorize this formula, and in the next video we will deep dive into the like word problem. For this video, just memorize this formula, write the formula once and twice. I've just make you understand the formula because it has the same logic in here. If you deep dive into the derivation, don't deep dive into it because you don't need it. Just memorize the formula. And for the word problem, I'm making a video, so bear with it.